Hi, welcome to the Bright Mind Academy's Past Question Clinic. In this video, another subsequent video, we'll be diving into the major examination in Nigeria's past question, treating each question and telling you the reason why each and every option is either right or wrong, thereby helping you to prepare better for your exam and making you ready to excel excellently in your upcoming exam. In this particular episode, we are going to be checking in with the UTME chemistry, treating the topic separation of mixture and purification of chemical substances. Let's dive in. At the end of this video, you should be able to identify and explain the different methods of separating techniques, understand the principle behind the separation and purification of substances. You should be able to develop critical thinking skill, and you should be able to apply this method. You should be able to apply this method to solve what? Practical problems. Now, let's quickly do a quick review of the topic before we go into the past question. The first thing is, what is a mixture? So, what is a mixture? Yes, I'm asking you, what is a mixture? Yes, you are right. A mixture is a combination of two or more substances that are not chemically combined together. A combination of two or more substances that are not chemically combined together. That's what we refer to as a mixture. A combination of two or more substances that are not chemically combined together. So, what differentiates a mixture from a compound is that what? The constituents of a mixture are not chemically combined together. So, what are the properties of a mixture? The properties of a mixture include, they have what? Indefinite composition. The composition changes. The composition are not definite. It changes from one form to another. The constituent identity, what? The constituents retain their identity. Individual component of a mixture, they retain their identity, and their reaction to the same condition differs due to the fact that what? Their identity is different. And also, they can be easily separated. The component of a mixture can be easily separated. If not because the component of a mixture can be easily separated, we are not going to have the topic separating techniques. It's due to the fact that the component of a mixture can be easily separated. That's why we have the topic separating techniques. So now, what are the classifications of mixture? Under the classification, we can classify mixture into based on what? Based on two particular factors. The first one is the number of phases, while the other one is the size of the particle. Based on the number of phases, we can classify mixture into homogeneous mixture and heterogeneous mixture. We can classify mixture into homogeneous mixture and heterogeneous mixture. An homogeneous mixture is a type of mixture in which the components of the mixture are in the same phase. Just like, let's say we are mixing petrol and kerosene together. The two are going to form a miscible liquid. So they are They are in the same phase that way. Or you are mixing something solid state with another thing in solid state. They are They are going to be in the same phase. But an heterogeneous mixture is like when we are mixing water with water with petrol. They are going to be in different phase. Because they are They are going to be in different phase. So based on the size, you can classify mixture into You can classify mixture into solution, colloid, and suspension. So the next one is talking about examples of mixture. So examples of mixture include palm wine that is made up of ethanol, sugar, organic acid, lipid, and so on. We also have muddy water. We have petrol that contains kerosene. We have petroleum that contains kerosene, petrol, diesel, gas, and so on and so forth. So, what are separating techniques? These are the separating techniques are the method that we use to separate the components of a mixture into their individual distinct components. A mixture, we said, contains different components that does not react together chemically. So separating techniques are those methods that we use to separate the components into their individual distinct and pure state, leveraging their preference in physical properties. leveraging their difference in physical properties. So we now have different type of what? Separating techniques, which include distillation, that is based on what? Their difference in boiling point. We have chromatography, which is based on how fast they can move across the what? Across the chromatographic plate. We have sublimation, that leverage the ability of a substance to sublime or not. We have filtration also. We have centrifugation, we have decantation, we have crystallization, we have evaporation, and so on and so forth. Now let's dive into the what? Into the questions, and let's see what we have. The presence of an impurity in a substance will cause the melting point to dash. May be stable, zero, reduce, or increase. What you have tend to notice is that the presence of what? The presence of impurity in a pure substance does two things. The first one is what? Is to reduce the what? Is to reduce the melting point. It is going to cause a reduction of what? Of the melting point. It is going to reduce the melting point. But increase what? It will increase the boiling point. It is going to increase the boiling point. It is going to cause increase in the boiling point. So here our answer will be what? Reduce. Our answer will have been increased, assuming what? Assuming this particular question is talking about boiling point, if it is not what? Melting point. The second one is saying that the principle of Coulomb chromatography is based on the ability of the constituent to dash. The first thing we need to know is what? What is Coulomb chromatography? Coulomb chromatography is one of the methods of separating techniques that we use to what? Separate color, dye, ink into their what? Constituent part, based on their ability to migrate over the what? Over the chromatographic plate. So now let's take a look at the option. Dissolve in each other, no. React with the solvent, no. React with each other, no. But move at what? At different speed over the what? Over the chromatographic plate. This is the what? This is the answer for this particular question. A branch of ink containing cobalt, copper, iron can be separated into various components by. Anytime you see dye, ink, color, they are always what? They are always separated by what? Chromatography. Sublimation is when the substance moves from solid state to gaseous state without passing through the intermediary liquid state. Fractional distillation is based on boiling point. Crystallization is based on what? Saturated. It's based on saturated solution. A pure solid usually melts dash. Usually, a pure substance melts over a what? Over a narrow range of temperature, or at a what? At a specific temperature. But mixture, they usually melt over what? Over a wide range of temperature. That's one of the difference that we have between what? Between a pure substance or an impure substance. Now let's take a look at the options that we have. Option A, over a wide range of temperature. That's for what? That's for mixture. Over a narrow range of temperature, yes. This is for what? This is for pure substance. At a lower range of temperature than the impure one. At a lower range of temperature than the impure one. This is inverse of the reality, because it is impure substance that usually have what? Has a lower temperature than the what? Than the pure. Then at the same temperature, no. Therefore, our answer for this particular question is going to be what? Option B. Crystallization exploits difference in which form? Crystallization is based on the ability of what? Ability of a solution to form what? To produce crystal, that is substance in solid state, from a what? From a solution. That is, if you reduce the temperature, the solubility is going to fall. The solubility of a saturated solution is going to fall, and it is going to what? Produce crystal. That is, substances are moving from what? They are moving from liquid state to what? They are moving from liquid state. They are moving from liquid state to what? To solid state. So specific heat, no, is based on heat transfer. Boiling point. Boiling point is the point at which a substance move from liquid to gas, right? So the change of state is not what? Is not coherent. It's not the same here. But for melting point is when you move from what? From solid to liquid, right? Therefore, our answer for this particular question is going to be what? Option C. And the last one, the next question is saying that the process whereby a gaseous body loses some of its kinetic energy to a colder body is referred to as dash. When a gas loses its kinetic energy, well, which state will it go to? It is going to go to what? Liquid. It is coming to liquid state. And the process is known as what? Condensation. Melting is from what? Solid to liquid. Evaporation is from liquid to gas. Freezing is from what? Liquid to solid. So the answer here is what? Condensation. Which of the following method can be used to obtain pure water from a mixture of sand, water, and methanoic acid? From what we know is that water and methanoic acid are miscible liquids, but sand is an insoluble solid. So we can separate an insoluble solid from a solution by By filtration. Since water and methanoic acid are miscible liquid, we can separate them by Distillation, leveraging their boiling point. Now let's take a look at the option. Neutralization with sodium hydroxide followed by filtration. Neutralization with sodium hydroxide is going to form methanoic acid, sodium methanoate, and that sodium methanoate is going to remain in the solution. So we are still forming another compound already, and we are not separating what we need to separate. Followed by distillation, we will not be able to separate These are our sand out. Fractional distillation only, we are going to separate the water and methanol, but sand will still be present as a mixture. So we are not getting what we need. Filtration is going to separate the sand out, followed by distillation. Distillation is going to separate the water and methanol. So the correct answer here is filtration followed by distillation. Which of the following is a physical change? What are physical changes? Physical changes are are reversible changes that does not form a new product. You see, freezing ice, if you freeze an ice, you can still return the ice back to back to normal state. So definitely that's a physical change. Dissolving calcium in water, this is a chemical change because it's going to form calcium hydroxide. Burning kerosene is going to form CO2 and water. So that's a chemical change. Exposing white phosphorus to air is a chemical change because phosphorus is going to be oxidized to phosphorus oxide. So it is also a chemical change. So the answer is freezing ice. Okay. In this question, we have that in countries where the temperature falls below 273 Kelvin, salt is always sprinkled on the icy road in order to dash. As I've said earlier, the addition of impurity to a particular substance usually lowers the melting point and increase the boiling point, right? So we are talking about the melting point here. So definitely it's going to lower the melting point. Although make the ice impure sounds reasonable, but the main reason why we are adding the impurity is in order to lower the melting point. Chlorophyll obtained from green leaf of plant can be shown to be composed of more than one color component by the technique of, as I've said earlier, whenever you see chlorophyll, color, dye, paint, ink, anything like that, it is usually separated by chromatography. It is usually separated by chromatography. Sublimation deals with movement of a substance from solid state to gaseous state without passing through the intermediary liquid phase. While crystallization deals with formation of solid from a saturated solution. A mixture of petrol and water can be separated through Okay, now, what do you think the answer is? Use of filter paper? No, because use of filter paper can always be used to separate an insoluble solid from a solution. Use of separating funnel? Yes. Why? Because they are insoluble liquids. Insoluble liquids are that can be separated with a separating funnel. Why distillation is used for soluble liquid with different boiling points. So the answer for this particular question is going to be our option B. So moving on, we have that a difference between chemical and physical changes is that one of the difference between chemical and physical changes is Yes, I'm asking you. What do you think the answer is? Yes, you are right. It's the formation of It's the formation of new substance. And another difference is chemical change are usually not reversible, while physical change they are reversible. The option C that is saying that oxygen is consumed is not all chemical reaction that involve the use of oxygen, and it is only physical changes that is reversible. It is only physical change that is reversible. Okay, moving on. This one is saying that the order in which a mixture of sand, ammonium chloride, and sodium chloride can be separated is dash. We need to first study the mixture that we have. We have the sand, which is an insoluble solid, ammonium chloride that can sublime, and we have sodium chloride that is soluble in water. So what can we do? What we can do is to first let the one that can sublime to leave, then we dissolve in water, then filter out the sand, then use evaporation to get back our sodium chloride. Next, let's take a look at the option which option do you think follows the right approach? Yes, you are right. It is what? Option A. That is what? Sublimation first, followed by what? Dissolution. After dissolution, we are going to use filtration to to remove the what? To remove this sand, then evaporation to get back our what? Our sodium chloride. Okay, moving on. The next question is saying that sugar is separated from its impurity by dash. Distillation, evaporation, precipitation, crystallization. What do you think the answer is? Distillation. Why? It cannot be distillation because we are not considering what? Two miscible liquids. It cannot be evaporation because what? We are not having a solution that can be recovered after the water dries off. And it is not precipitation because we are not having a solution of what? A solution of concentrated. It cannot be what? It cannot be precipitation too. The answer will be what? Crystallization. We are going to get what? The crystal form of the sugar from the what? From the saturated solution of the what? Of the sugar by lowering the what? By lowering the temperature. So the answer will be what? Crystallization. Moving on, the question says a mixture, a heterogeneous mixture can be defined as any mixture that dash. As I said earlier, when we are trying to do an overview of the topic, I said what? An heterogeneous mixtures are mixtures that are what? Are in different phase. So let's check. What do you think is the answer like that? That are uniform? No. Whose component is not uniform? Yes. Formed by solid and liquid? Not necessarily. A solute and solvent? No. So the answer here is what? Whose component is not uniform. The property used in the industrial preparation of nitrogen and oxygen from air is what dash? Air, as we know it, is a mixture of different gases that include what? Air, oxygen, CO2, natural rare gases, water vapor, and a lot of them. So they can be separated into their components using the what? Using fractional distillation. Fractional distillation. We can use what? Fractional distillation to separate them. And fractional distillation is a form of what? It's a form of separating techniques that is based on what? That is based on the boiling point of the what? Of the particular mixture, of the particular component present in the what? Present in the mixture. So the answer for this particular question will be what? The boiling point. Moving on, a chemical reaction is always associated with dash. A chemical reaction is always associated with dash. An increase in the composition of one of the substance, change in volume of reactant, change in nature of reactant, formation of product. A chemical reaction is a chemical change and it always accompanied by the formation of what? Formation of new substances. This option, an increase in the composition of one of the substance, is already breaking the law of conservation of matter. So it's wrong. A change in volume of reactant. Definitely the volume of reactant are going to change. But it's not necessarily like the volume of the reactant are going to change since the reactant are going to be converted to product. Change in the nature. Since the reactant are being converted to product, their nature is going to change since they are forming a new substance already. But the most important thing is the what? Is the formation of what? Formation of new substance. This is the most important thing here. So moving on, question 19 is saying that when a solid substance disappears completely as a gas on heating, the substance is said to have undergo dash. So what do you think is the answer? I've said something related to this before. Crystallization? Is that what you are trying to say? Definitely not. I believe you are saying that what? The answer is sublimation. Chromatography separation of ink is based on the ability of the component to dash. I think we have solved this question before. Yes, it is option D. Ability to move at different speed in the column. A mixture of iodine and sulfur crystal can be separated by treatment with what? So what we need to know is what? To first study these two substances that we have. Sulfur and what? Sulfur and iodine. Iodine is partially soluble in water, while sulfur is what? Is insoluble in water. Now let's take a look at it. Water to filter off sulfur. Is this the correct answer? Definitely not, because what? Iodine is a sparingly soluble what? Substance. So if you dissolve iodine in water, it will not dissolve completely. So by the time you are filtering off sulfur, some iodine is going to go with it. Definitely this option is not correct. Methanol to filter off iodine. This is also wrong because what? Because sulfur is not soluble in what? In methanol. So this also is wrong. So the correct answer is what? Option D. Because what? Carbon 4 sulfide is going to what? Is going to dissolve sulfur completely. Thereby we can what? We can easily filter off iodine from the what? From the mixture. A pure substance or pure solvent are obtained by dash. When we have a mixture of different solvents and we want to get the pure form, one of the best way to get it is by what? Is by distillation. Because in distillation, the liquid present in the jar are going to what? They are going to form gases. So as the gases are leaving the what? As the gases are leaving they are moving from the liquid state into the gaseous state. We can what? We can condense them again in another what? In another container that is cooler. So if you condense them in another container, we are going to have what? The pure form of the what? Of the particular solvent we are trying to get. So distillation is the best way to get what? Pure solvent from a what? From a mixture. Distillation is the best way. So sieving is a method used to separate mixture containing solid of what? Particles of different size. You see, sieving is something you do every day at home. It's something we do every day at home. We get a sieve, then we pour something of different sizes there. Those ones that are smaller than the size of the sieve, they will get what? They are going to go under the what? They will go under the sieve. While those bigger than the size of the sieve, they are going to remain in the what? In the sieve. So sieving is what? It's used to separate particles of what? Of different size. If they are of the same size, there will not be separation. It is not necessarily they are smaller size. It is not necessarily they are larger size. So the answer is what? Different size. A mixture of iron and sulfur can be separated by dissolving the mixture in dash. A mixture of iron and sulfur can be separated by dissolving the mixture in dash. So what do you think is the answer here? In steam, no. Methanol to filter iron. Sulfur is not soluble in methanol. Dilute sodium hydroxide, no. But in benzene, yes. Sulfur is soluble in benzene. Then we can filter off what? Iron from there. So it is what? Option D. The addition of water to calcium oxide leads to dash. If you add calcium oxide, calcium oxide to water, it's going to give you calcium hydroxide. It is going to form calcium hydroxide. It is going to give us calcium hydroxide. It is going to give us calcium hydroxide. So definitely it is what? It is a chemical change. It is a chemical change. Which of the following is an example of a chemical change? A chemical change is a change that involves what? Formation of new product, and it's not what? It's not easily reversible. Let's take a look at it. The first one is saying dissolution of salt in water. Since we can recover the salt by evaporation, it is a what? It's a physical change. Rusting of iron. Iron is going to move from iron 2 to iron 3 when it's exposed to what? Exposed to air in the presence of water vapor. So that's a chemical change. Melting of iron. We can cool the iron back to get the solid iron. So it's a physical change. Separation. No. So the answer here is what? Rusting of iron. Chromatography is used to separate components of mixture which differ in their rate of what? As I've said something related to this earlier, their speed in the what? The speed with which they move along the colon. So definitely it's not their fission, it's not reaction, it's not sedimentation, but what? Their ability to migrate. Their ability to what? Their ability to migrate. Moving on. A chemical reaction is always associated with dash. I think we have come across this question before. It's the summation of this substance. Properties used in the industrial. Okay. What do you think the answer is of this is? Yes. What's the answer of this particular question 29? The property used in the industrial preparation of oxygen from air is dash. What is the answer? Definitely you are right. It is what? Boiling point. We have come across a question that is similar to it before. Moving on. A small quantity of ammonium chloride was heated gently in a test tube, the solid gradually disappeared to produce a mixture of two gases. Later, a white cloudy deposit was observed on the cooler part of the what? Of the test tube. Ammonium chloride is said to have undergone dash. So what has it undergone? Moving from what? It has moved from solid state to gaseous state without undergoing the what? The intermediary liquid state, right? That is definitely what? sublimation. That's sublimation. Moving on, which of the following change is physical? Definitely, what do you think the answer is? Adding iron filling to aerated water, no, it's going to form a compound. Adding sodium metal to water, no, it's react and form sodium hydroxide, liberating hydrogen gas. Cooling water to what? To obtain ice. Definitely, this is a change of state. And I've told you, whenever there is a change of state from solid to liquid, liquid to gas, gas to solid, they are what? They are physical changes. Burning of domestic gas, this is a combustion reaction. It's a chemical what? A chemical process. By means of filtration, one component can be obtained pure from an aqueous mixture of sodium hydroxide and dash. Which of the following can we obtain using filtration? What we know is that potassium nitrate and lead nitrate, and generally nitrate salt, they are soluble. Definitely these two salts will be soluble. Sugar is also soluble, so we cannot use filtration. Definitely it will be sand. Sand is the what? Sand is the insoluble part of the what? Is the insoluble part of the option we are given. Methanoic acid mixed with water in all proportion, that is what? They are miscible liquid, and has the same boiling point as water. Which of the following method will you adopt to obtain pure water from sand and methanoic acid? The first thing we need to do in this question is to get out the sand. We need to get out the sand first. So we can get out the sand by what? Filtration, followed by what? Fractional distillation to what? To separate water from methanoic acid. So which of the options is making sense? Esterification with this is going to form another compound. Neutralization, this is going to form another compound. We are just complicating the issue for ourselves. This is also form another compound. We are just complicating the issue. The only thing we can do easily to separate is what? Fractional distillation. Fractional distillation. In an attempt to remove sugar from a beaker containing quantity of sugar, sand, 2 ml of ammonium chloride was accidentally added. And we already know that what? Ammonium chloride sublime, right? Ammonium chloride sublime. So, which of the following method can be used to remove the ammonium chloride from the solution? Since we know that ammonium chloride sublime, anyone containing sublimation is what we are going to. If you use fractional distillation is just fractional distillation cannot be used because what? We don't know, because ammonium chloride is what? Ammonium chloride has the ability to sublime. So sublimation is the best way. Crystallization, no, we are not having a saturated solution here. So filtration to remove the sand followed by what? Sublimation is the what? Is the right answer here. Is the right answer here. Which of the following compound and element will sublime on exposure to the what? To the atmosphere? We have ice, we have sulfur, we have phosphorus, we have iodine. Okay, let me give you a particular mnemonym that you can use to what? To remember the major substance that do sublime. We have around 5 of them. There may be more, but these 5 are what you are going to come across majorly in your exams. C is standing for camphor, A is standing for ammonium chloride, N is standing for naphthalene, I is standing for iodine, and D is standing for what? Dry ice. This dry ice is different from this ice. Dry ice is what? Is the solid form of carbon 4 oxide. So from this option now, we can definitely see the answer is what? Our answer is option D. Although sulfur can sublime, but sulfur sublime only when heated. So, and the question is saying that what? On exposure to the atmosphere. So the right answer in this question is what? Option D. Okay, moving on. This question is saying that which of the following does not lead to a chemical change? So definitely one of them will be what? One of them is going to give us a physical change. Stirring iron in sulfur 4 oxide. That will definitely form what? Iron sulfate and what? And hydrogen gas. Definitely that's a chemical reaction. Stirring glucose in concentrated sulfur 4 oxide. Since sulfur 4 oxide is a dehydrating agent, it will lead to charring and formation of carbon. So this is a what? A chemical process. Titration of acid and base is also what? A chemical reaction. Definitely the answer will be what? This. The answer will be option what? Option B. Is just a dissolution what? It's dissolution process. So moving on, a mixture of common salt, ammonium chloride, barium sulfate can be separated by. Let's take a look at this. Ammonium chloride can sublime. Barium sulfate is insoluble in water. Common salt is soluble in water. So we can first let this sublime. After this sublime, we dissolve it in water. On dissolving in water, then we can what? Get this barium sulfate out. Once we get the barium sulfate out, we can evaporate the water again to get back our salts back. So let's see the one that followed that approach. Addition of water, yes. Followed by filtration, yes. Then sublimation, no, sublimation should come first. Addition of water followed by sublimation, no, sublimation should come first. Sublimation, yes. Followed by addition of water, yes. Then filtration, yes. This is the what? This is the most correct option and the most logical. Sodium chloride can be obtained from brine by that. What is brine? Brine is a what? A solution of what? A solution of sodium chloride. Like if you dissolve sodium chloride in water, you get what? You get brine. So you can obtain sodium chloride from brine by what? By evaporation. So you cannot use distillation because the two of them are not solution. You can get it by evaporation. If you heat the water to the solution to dryness, you are going to get back the what? The sodium chloride. Since it's just what? Brine is just what? Addition of water to what? To sodium chloride. If you dissolve sodium chloride in water, you are going to get brine. This question is saying that in an experiment, which of the following observation will suggest that the solid is a mixture? So what we know for mixture is that what? They usually don't have what? A static, like they usually have a wide range of what? Boiling and melting point. So the solid can be grinded to fine powder. Both pure and impure substance can undergo this, so it's not a distinct function. Density of 2.5. For it to have a definite density like this, it must be a what? A pure substance. Solid begins to melt at 573, but it's not completely melted until 624. You notice something. This is a what? A wide range of what? A wide range of temperature. Definitely this is the what? This is the correct answer for this question. Solid absorbs moisture from the atmosphere and turn into liquid. No. Solid metal. No. So the answer for this question is what? Option C. Moving on, which of the following substance is a mixture? Graduated sugar is not a mixture. Seawater is going to contain what? A lot of stuff. It's going to contain water, sugar, salt, debris, fish, and a lot of stuff. Definitely seawater is a what? Seawater is a mixture. But sodium chloride is a compound on its own. Iron filings is what? Are just ions. Like just small ions. Like is iron filings. So it's a compound. It's an element on its own. So the answer to this question is what? Our option C. Option B. Which of the following we support the conclusion that, okay, I think we have come across this particular question before. Okay, yes. It is what? Option C. Which of the following is a physical change? Bubbling of chlorine into water. If you add chlorine gas with water, it's going to form two things. We add chlorine, Cl2 plus water, Cl2 plus water, is going to give us two things. It's going to give us HCl, Cl2 plus water, it's going to give us HCl, it's going to give us HCl and what? Hypochlorous acid. That is HO it's going to give us HOCl. So this is a chemical change. Bubbling of chlorine into a jar of hydrogen gas. This is what just going to give us what? Hydrochloric acid, HCl, hydrochloride. The dissolution of sodium chloride in water. This one we can get the sodium chloride back by what? By evaporation. So it's a what? It's a physical change. This is the answer to the question. And passing of steam over heated iron. This is also what? It's going to form iron. It's going to form iron oxide and what? And hydrogen gas. It's going to form iron oxide and hydrogen gas. So this is also what? A chemical change. Which of the following can be obtained by fractional distillation? Nitrogen from air, sodium chloride from seawater, iodine from a solution of iodine in carbon tetrachloride, sulfur from a solution of sulfur in disulfide. Which of the following is the answer? By fractional distillation. Yes, we have talked about it before. Yes, you are right. The answer is what? Option A. Option A. Which of the following are mixture? Petroleum, rubber latex, vulcanizer, Solution carbon 4 sulfide. What's the answer? B? Are you sure? Okay, A now. Yes, you are right. The answer is what? Option A. Because what? Petroleum is made up of a lot of stuff. Petrol, kerosene, diesel, natural gases, a lot. Rubber latex is also made up of a lot of stuff. Rubber, water, and a lot. This one too is what? Is a solution that it contains a lot of material. But we all know is what? What we know is that carbon sulfide is a what? Is a compound. Carbon sulfide is a compound. That is what? Any option containing it is what? Is wrong. So our answer is what? Option A. Which of the following is not an homogeneous mixture? You know, when we are talking about mixture, when we are dividing them based on what? Based on phase, we say we have homogeneous and what? Heterogeneous. The question is now asking us which of the following is not homogeneous. That is what? The components are not in the same phase. Filtered seawater, that is what? We have removed all the debris from the seawater. Definitely it will be what? Homogeneous. Your soft drink is homogeneous. But flood water is going to contain sand, mud, bottles, a lot of stuff are going to be present inside flood water because it is going to contain what? A lot of material. So it is not what? It is not homogeneous. And your writing ink is what? Is homogeneous. You cannot say that, oh, this is this component, this is that component. They what? They mix together. The dissolution of common salt in water is a physical change because why? Because what? Why do we call the dissolution of common salt in water a physical change? Why? Okay, I'm listening. Yes. You said because we can recover it by evaporation, right? Yes, you are right. It's because what? We can recover it by what? By evaporation. It's because we can recover it by evaporation. Which of the following substance is a mixture? We have sulfur powder, bronze, distilled water, ethanol. Which of the following do you think the answer is? Okay. Yes, you want to try, you can try. Yes. It is what? It is bronze. Because what? Bronze is formed from what? Two different metals. Copper and what? Copper and tin. Copper and tin. Mixture of copper and tin. Bronze is an alloy. Copper and tin is what form what? Is what form bronze. Copper and tin. Copper and tin is what form bronze. We also have something that's very close to it too. Brass. That one is copper and zinc. Copper and zinc is for brass. Copper and zinc is brass, but this bronze is what? Copper and tin. Sulfur powder is a single element. Distilled water is what? Is a pure water. Ethanol is a compound. So they are what? They are not mixture. A little quantity of trichloromethane that is at 60 degree, the boiling point is at 60 degree, was added to a large quantity of ethanol. The boiling point is at what? 78 degree. The most probable boiling point of the resulting mixture is dash. We have 69 to 70, 82 to 84, 60 to 78, 70 to 74. What do you think the answer is? Yes, you are right. The answer is going to be what? The answer is going to be option D. That is what? 74.70 to what? To 74. Why? Because the larger component of the mixture is what? Is ethanol. The temperature is going to be very close to it. But it will not be exactly at what? At ethanol. Because of the presence of what? The presence of the trichloromethane. So the answer will be what? Very close to it, but not exactly at it. It cannot be up to 78 because what? It's a mixture already. It cannot range between the two. And it cannot be more than it. And it will not be this. It will what? It will be this 70 to what? 74. The letter S, Y, and Z represent what? So we are moving from solid to gaseous state for X. That's what? Directly from solid to gaseous state without passing through the what? This intermediary liquid state. That's what? That's sublimation. So X is sublimation. Let's check the option which one is starting with sublimation. This one is starting with freezing. So it is out. This option is out. So we don't need to consider it again. This option is out. We don't need to consider it. Evaporation. No, this option is also out. We don't need to consider it. So we are considering these two options, A and B. So our Y is saying that what? From gaseous state to liquid, that's what? Condensation, right? It's when we are coming from liquid to gas. That's what? Evaporation. So the answer is what? Option A now. Because option B is saying vaporization. So the answer is what? Option A. Okay, to the last question of the day. The question is saying that in the experiment above, ammonium chloride crystal deposit on the wall of the tube as a result of dash. We already know that what? Ammonium chloride is sublime. And when heated, it's going to move from what? From solid state directly to what? To gaseous state. So if you move from solid to gas when heated, to gas when heated, definitely when it is cool, it can definitely move back to what? Move back to solid. And that's what happened here. Because what? This side of the what? This side of the tube is cooler. The gas that is formed after heating here, they turn back to what? To solid state here. So the process is what? Are you saying evaporation? Definitely not. I trust you will not say that. So the answer should be what? Sublimation. The answer should be sublimation. And with that, we have come to the end of the what? Of the PT question on the what? On the separation of mixture and purification of what? Chemical substance. So by now, I believe whenever you see any question under what? Under this particular topic, you will be able to what? You will be able to solve them without what? Without any iota of doubt in you, knowing that what? You fully understand the topic and you know the pattern with which you are going to ask you what? The question in your what? In your upcoming exam. To prepare you better against your exam, we have created what? A quiz for you on this topic to test your what? To test your knowledge, to test whether you have already know what you said you have known. So we have kindly check the what? Kindly check the pinned comment under this video. You are going to see the link to the quiz. Kindly take the quiz and you get back to us. Let's see what you have from the quiz. I believe you are going to do amazingly well. I'm expecting 100% pass mark from you. So thank you for watching and thank you for staying to the end. Kindly like and subscribe our video and comment. In case any part of the video is not clear, you can contact us via the comment section and see you in the next episode. Bye.